Today we're going to talk about solving radical equations. Our main focus would be on solving square root equations, but at some point we will discuss higher order radical equations. So let's start with a certain fact. We've accepted that if you take a square root of a number, something like 9, the outcome is a positive value. It's never negative 3. Even though negative 3 squared 9, we say when you take a square root of 9, the outcome is always positive 3. If you want to have two solutions, if you're solving an equation like x squared equals to 9, when you take the square root, you consider plus or minus. That's why we want to have positive and negative 3. So we always accept the fact that the outcome of the square root is a positive number. So here we have, if you have square root of x equal to some constant, c is a constant, that constant must be a non-negative value. It could be 0, but if it's non-negative, then you can solve this equation. Otherwise, you have a square root that equals to a negative number, which is impossible. We've accepted that the outcome of square root must be a positive value. So if you have square root of x equal to c, then what is x? X would be c squared. You can think about it that if you had square root of x equal to c, what you do is you square both sides, and therefore left side square root of x squared is simply x, right side is c squared. So therefore I have x equal to c squared. A very simple example is if you have square root of x equal to 9, let's say 3. What is x? X is 3 squared, which is simply 9. Square root of 9 becomes 3. But if it was negative 3, if you had square root of x equal to negative 3, then when you square both sides, x would be negative 3 squared, it would give you 9. Square root of 9 is not negative 3, it is positive 3. So this is impossible to have a solution for, well as this is not correct. Okay, so we use this rule that you can square both sides if both sides are non-negative. You can do this and say I square both sides, but you have to check your solution at the end to see, does it really satisfy the equality or not? So this is an important factor to consider, that outcome of square root is always a positive value. Let's look at some simple examples. This is the very simplest case. You have one single square root and you have a constant on the other side of the equality. So we have square root of 2x minus 4 equals to 3. What do? You square both sides of the equality. I'm going to write that. 2x minus 4 squared equals 3 squared. I could do that because the other side is a positive number. Even if it was negative, you could still square both sides, but at the end you always have to check your solution for the radicals. So let's square both sides. What do we get on the left side? Square root and squared are opposite operation. So left side is simply 2x minus 4. Right side 3 squared 9. Now you have a linear equation. Add 4 divided by 2. What is x? 9 plus 4 is 13 divided by 2. Shall I check the solution? You always check your solution if you're dealing with square roots. So square root of, here, this is, you check your solution. Since we haven't talked about domains of functions, that's why we check our solution. Sometimes, if you remember in rational cases, the denominator could become a 0, so you cannot accept that solution. For square root, is the same idea. But instead of having denominator 0, you will get negative number underneath the square root, which is going to give you a complex number. We're not going to deal with complex number at this point. So I'm replacing 13 over 2 for x into the original equation. 2 times 13 over 2 minus 4, is it equal to 3? You simplify it underneath the square root. 2 times 13 half is 13 minus 4, is it equal to 3? 13 minus 4 is 9, square root of that is 3. So therefore I have 13 over 2 as my solution set. Solution set is 13 over 2. Sometimes it's enough just to box this and say this is the solution. But if they ask you for the solution set, try to write it in this format. Okay, let's look at the next example. In the next example, what do? if you have a constant on one side and the other side contains a square radical, you always the idea is to isolate the radical. Whatever it is, I see a radical, I will isolate it. That means I will get rid of every other term. I will subtract 9, subtract 9. So what do I get on the left side? I will get -3 equals to square root of 5 minus 3x. Here's an important thing. At this point, if you look at the left-hand side, what do you see is a negative number. Right-hand side is square root. At this point, I can say this equation does not have any solution. I can say no solution simply because radical, you can never have a negative outcome. I can say no solution. But let's say if you make the mistake and square both sides, what happens? So this is with the assumption that I didn't notice that the left-hand side is negative. And I'm still following with the same idea. I will square both sides. Square root of 5 minus 3x. Square both sides. -3 squared is going to be positive 9. Do not write -9. You have to use parentheses when you square both sides. Right-hand side is 5 minus 3x. Okay. Now subtract 5 from both sides. You'll get 4 equals -3x. What is x? Divide both sides by -3. It becomes -4/3. So this is not a solution at the moment. This is a possible solution that you have to check. What if I check that solution? If I replace -4/3 into the original equation, 6 equals 9 plus square root of 5 minus 3 times -4/3. What does it simplify to? 6 equals 9 plus square root of 5 minus -3 times -4/3. The negative becomes positive. 3 times 4, 12 divided by 3 is 4. So what do I have is 6 equals 9 plus square root of 9. Square root of 9 is 3. I have 6 equals 12. As you see, you will end up with a contradiction. This is not possible. By checking that solution, that means I cannot accept this solution. Therefore, no solution. That means even if you make the mistake and you don't see this negative equal to a square root, if you skip this step and say there is no solution and go through the process, at the end, by checking your solution, you can always figure out that, okay, maybe I made a mistake. So it is important to check your solutions. Sometimes it's just not possible to see that one side is positive, one side is negative. So you can go through the same process as always and check your solution. Okay, how about this one? Now I have 2 square roots. This is another case. In the other examples, we had only 1 square root. If you're dealing with 2 square roots, in this very simple case, you don't have to do that much. You just square both sides. So I will say, I will always isolate. If they were next to each other, I will move one to the other side. So I will square both sides. I'm going to write this in step by step. Square both sides. Okay. What happens on the left side is you simply get 2x plus 1. Right hand side is 7 minus x. Okay. This is a linear equation. Move everything to one side. Solve for x. Okay, so I'm going to add x to both sides. Plus x. Subtract 1 from both sides. Minus 1. By doing that, these two -1 will cancel out. The two x's will cancel out. 2x and x, 3x. And I have 6. X becomes 2. Okay, again, even if you have 2 square roots, you still have to check your solution. So let's try to check this solution. Is 2 really a solution? We can replace it. 2 times 2 plus 1. Is it equal to square root of 7 minus 2? The left hand side is 5, right hand side is 5. I have a true statement. Square root of 5 is definitely equal to square root of 5. So the solution set. Sometimes do not make this mistake and say square root of 5 is the solution set. This is not correct. Solution set is what x was that you replaced into the equation. that satisfy the equation. 2, this is the solution set. Okay. Let's try the next example. We have one radical, and on the other side you do not have a constant, you have variable. There is no difference than if it was a constant. You still do the same thing. If it was more than, let's say, I will have another example later. So let's deal with this one first. So let's say, what do? I always isolate the square root. In this case, it's isolated. It means it's by itself on one side. Then I will square both sides of the equality. Normally, this is a good idea to keep the original equation always. If you want to square both sides, square it in the next line. Because if you're checking your solution, you want to check it in the original equation. So I will do this. I will write the equation down again. Now I will square both sides. What do I get on the left side is 7x plus 8. What do I get on the right side? X plus 2 squared. You can write that twice. What is x plus 2 times x plus 2? There is a shortcut to it. But if you don't remember, you can always do this. Distribute. Let me do this. Sorry, I think I drew so many lines. Let's go back a bit. Okay. X times x, x times 2, 2 times x, and 2 times 2. This becomes x squared plus 2x plus 2x plus 2. So simply you will get x squared plus 4x plus 4. That is not 2 at the end. This is 2 times 2, which is 4. Okay, so now you are solving this equation, which is a quadratic equation. Move everything to one side. You can subtract these terms, or you can subtract 7x minus 8. Does not really matter. It's easier to subtract these two. Negative 7x minus 8. So what do I have? I have 0 on the left side. Right hand side is x squared. 4x minus 7x minus 3x. Positive 4, negative 8, it becomes negative 4. Here's one important thing. Again, I think I've mentioned this before. If you have this equation and you're not comfortable with having 0 on the left side, you can rewrite it and say x squared minus 3x minus 4 equal to 0. This is what you're solving. It doesn't really matter if 0 is on the left or right side. The rearranging sometimes is easy to see it that, okay, now I have a quadratic equation. How do I do? What do? I will factor it if possible. If not possible, I will use quadratic formula. In this case, it is possible to factor. The factors are negative 4 and plus 1. You add them together, you'll get negative 3. Multiply, you'll get negative 4. So what are the solutions? There are two solutions. Either x plus 1 equals to 0. Here, let's continue up here. Or x minus 4 equal to 0. I hope that at this point, this is not an issue. So either x equals to negative 1 or x equals to 4. Okay, just because you have a negative number, you cannot say this negative does not belong to the solution set. You have to check your solutions, or if it's positive, does not mean that positive number belongs to the solution set. You always have to check your solution. So let's try to check our solution. If I replace negative 1, let's try negative 1. What do I get is square root of 7 times negative 1, use parentheses, plus 8 equals negative 1 plus 2. 7 times negative 1 is negative 7, plus 8 is 1, so I have square root of 1. Right hand side is negative 2 plus 1 is 1. This is a true statement, so this is an acceptable solution. I can accept that. If we check 4, what do we have is, let me scroll down a bit. Again, I'm replacing it in the original equation. This is test for x equal to negative 1. What if I check x equal to negative 4? Sorry, positive 4. Then I will get square root of 7 times 4 plus 8 equals 4 plus 2. Left hand side, 28 plus 8 is 36. And right hand side is 6. Square root of 36, positive 6. This is acceptable as well. So x equal to 4 is the solution as well. So we have two solutions. Solution set is negative 1 and 4. Okay, so make sure that you check your solution. It's not always acceptable solution. And having a negative number does not mean it's not an acceptable solution, or having a positive number does not mean it's always acceptable. You always have to double check your solution. Okay, let's look at this one. If you look at this example, you have the square root and you have negative m plus 2. Here's one common mistake. You cannot do this. You cannot square here and say everything squared. This is not acceptable. You cannot square term by term. You have to square the whole thing together. But if you square everything together, then it's not going to help you get rid of the square root. If you do this, it does not help you get rid of the square root. If you have x plus 1 squared, this doesn't mean x squared plus 1 squared. This is not correct, right? This means x plus 1 times x plus 1. That's what it means. So if you square it like this, what do you have is square root of m plus 18 minus m plus 2 multiplied by square root of m plus 18 minus m plus 2. That's what it means, which is not going to help you that much. It's going to be messier and more difficult to solve. So what you do is you do not square the whole thing. You always want to isolate the square root. I'm going to go backward. I know it takes a long time. Okay, so what do? I will first isolate the square root, m plus 18, and add m and subtract 2. So what do I get is positive m minus 2. I'll move m plus 2 to the other, negative m plus 2 to the other side. Now I have isolated the square root. I can square both sides. Again, make sure that you square both sides using parentheses. What does left side become? It becomes m plus 18. What is right hand side? Again, m minus 2 squared does not mean m squared minus 2 squared. It means you write m minus 2 multiplied by itself. And if you do that, you'll get m squared minus 4m plus 4. Try that as a practice just to make sure that you know how to get m minus 2 squared. It's very similar to the other example. Again, move everything to one side. I'm subtracting m, subtracting 18, minus m minus 18. What do I get is m squared minus 5m minus 12. Equal to 0 on the left side, but I'm going to write it on the right side. Doesn't make any difference. So can I factor it? Not always possible to factor. Let's try to see if we can find factors. Does 6 and 2 multiply gives you 12, but there is no way you add them to get negative 5. There is 4 and 3. If you multiply, you'll get 12, but there is no way to get 5. So in this case, maybe it is not possible to factor. Or maybe I don't see it. You don't always have to look for a factor. You can use quadratic formula. So let's try quadratic formula. M equals negative 5. It's minus b. So it is 5 plus or minus square root of did I make a mistake anywhere? I don't see. So hopefully sorry, this is not minus 12. Let me go back. This becomes a mistake that I didn't see. Here, positive 4 and negative 18 is not negative 12. It's negative 14. Equal to 0. Sorry about that. Yeah, I make mistakes too, but make sure that you catch me. And if you already caught me, that's a great way that you can see that I'm a human as well. Okay, so now maybe I can factor this one. 7 and 2 multiplied by each other gives you 14. So I have 7, 2, and I want to get negative 5, so minus 7 positive. It's easier this way to factor. At least I can get the solutions. One is negative 2, or m equals to 7. And again, check your solution. So check. If I replace m equal to negative 2, does it really satisfy the equation? So let's try it. Square root of negative 2 plus 18 minus negative 2 plus 2. Is it equal to 0? Negative 2 plus 18 is 16. Square root of 16 becomes 4. I have negative 2. I'll get positive 2 and plus 2. As you see now, what you have is 4 plus 2 plus 2, which is 8. 8 does not equal to 0. So this is not correct, because this is a false statement. I cannot accept it. M equal to -2. What if I try M equal to 7? What do I have? Is square root of 7 plus 18 minus 7 plus 2. Is it equal to 0? 7 plus 18 is 25. Square root of 25 is 5. So I have 5 minus 7 plus 2 equal to 0. In this case, yes, this is a true statement. So M equal to 7 is the solution. So my only solution set is 7. Try to be more organized than what I wrote. Normally I write better on the paper, but yeah, try to be organized in a way that you know what is the next step, what do I do next, and so on. Okay, these are mostly the types of radicals that we deal with. There's square root, second order of radical, but here we have a couple of examples of higher order. There's no difference. If you have cube root of x equal to 3, that means what number you have to multiply by itself 3 times to give you, let me write it this way, sorry. If you had a number that multiplied by itself and give you 3, sorry, it give you 27, go back. Give you 27, you could see that that number is simply 3, right? This is 3 times 3 times 3 equals 27. This is the idea of x cubed. That is what x cubed means. What does cube root means? That means if I give you cube root of 27, it means what was that number that you had to multiply it by itself? So cube root of x, that means you're looking for that number. If you multiply it by itself, it gives you 27. In this case, you're given that number, you're given 3, and say okay, if you multiply 3 by itself 3 times, what do you get? This is your result, 27. But you cannot do this always. So what you can do is, if the right hand side was a variable, what you can do is exactly the opposite operation. Last time, if you had square root, you raise both sides to power 2, you square both sides. This time, if I have a cube root, let me change the number. So if it was x cube root of x equal to 2, what do? I'll cube both sides. I'll do opposite operation. This cube root and 3 are inverses of each other. They will cancel out. Left side becomes x. 2 cubed means 2 times itself, 8, 3 times. So I'll get x equals to 8. 2 times 2 times 2. Higher order, 3, 4, and so on, it's exactly the same thing. If you have nth root of a number equal to a constant a, then what is x? X equals a to the n, because what you can do is you can raise both sides to the power n. Left side simply becomes x, right side is a to the power n. And you always have to check your solution. In cases of odd root, you basically do not need to, because the outcome of odd root could be positive or negative, but it's always important. Sometimes you make a mistake in calculation. Check your solution if possible. Okay, let's try this example. If it was square root, what would you do? You would isolate it. If it's cube root, you do exactly the same thing. You isolate. So what do? This is -4 times cube root of 2x minus 5 plus 6 equals 10. So I'll subtract the 6 from both sides. I'll get 10 minus 6, which is 4. Okay, there is still a -4 outside. Multiply by this. I want to get rid of that. So I'll divide both sides by -4. So what do I get is cube root of 2x minus 5. Divide both sides by -4. It becomes -1 on the right hand side. So now what is the next step? Next step is I isolated the cube root. I want to get rid of it. I'll cube both sides. Cube root of 2x minus 5 cubed, it's 2x minus 5. And -1 cubed means -1 multiplied by itself 3 times is still -1. Solve for x. 2x equals, add 5 to both sides, it becomes 4. Divide both sides by 2, x is simply 2. Do I check the solution? Of course, you always have to check your solution. So let's try to check the solution. Check. How do I check it? I will go back to the original equation. That's why normally I do not mess up the original equation. Because if you try to cube it here and later on when you look at the equation, you don't really see what was the original equation. So let's try x equal to 2. -4 times square root cube root of 2 times 2 minus 5. Is it equal to, sorry, plus 6 equals to 10. Okay, underneath the cube root is 2 times 2 is 4 minus 5 is -1. So I have -4 times cube root of -1 plus 6 equals 10. Here's important that square root of -1 is imaginary number I, but cube root of -1, that means cube root of -1 means what number multiplied by itself 3 times gives you -1? -1. Multiply by itself 3 times, it gives you -1. So therefore, cube root of -1 is simply -1. This is -1 times -4 is 4. 4 plus 6, 10. This is a true statement, so therefore x equal to 2 is the solution. So solution set, sorry. One more, solution set is x equal to 2. Okay, let's try this example. Most of the examples are very similar to the square root, so that's why I didn't really focus on the higher order. Because if you solve radicals with the square roots, every other higher order is exactly the same operation. So what do I do here? I have 2 of them. I will isolate them. I will get rid of them. Get rid of one of them. I will add this term to both sides. So what do I get is 2. This is 4th root. It's not 20. 4 is 2 4th root of 5y minus 4. And if you add that 4th root to both sides, you'll get 4th root of 2y plus 14. Here, you cannot get rid of this 2 outside. If you divide both sides by 2, on the left side, you will have divide by 2, which is not going to make it easier. So at this point, what I'm going to do is I'm going to raise both sides to the power 4. But I want to show you that something is a bit different. You cannot cancel out these 2 right away, because there is some term outside. So what you can do is you can say, okay, I can write them as 2 to the power 4. This 4 operates on both of them. This guy to the power 4, as well as the cube root, the 4th root of 5y minus 4 to the power 4. You could do that since it's multiplication. If it was addition, you couldn't do that. But since multiplication, it is possible. And right hand side, simply the 4th root and 4th root will cancel out, and to the power 4 will cancel out. So you have 2y plus 14. Left hand side, now here you have a 4th root. This 4th root and the power 4. These guy can cancel out as an operation. So you have 2 to the power 4 is 2 times 2 times 2 times 2, which is 16 times. And what is left is 5y minus 4. Right hand side is 2y plus 14. Hopefully at this point it's a linear equation. You distribute this into each one. So 16 times 5y minus 4. It's a bit larger than I was hoping for, but let's go through it. 16 times 5 is 50, 30, 80. 80y. 16 times -4, that is 2 to the power 6, which is 64, I believe, equals 2y plus 14. I do not have a calculator in front of me, so if I make a mistake, try to catch me and fix it. It's the idea that is important, how you do it. Okay, it's a linear equation. Move everything to one side. Here I'm going to continue up here. Actually, let me continue down there so we can check our solution later. So here's 80y, I'll subtract 2y from both sides and add 64 to both sides. 64, subtract 2y. What we get is 78y equals, these 2 will cancel out, these 2 will cancel out, 64 and this is 78 as well. Oh, this looks correct already. Y equals 1. So let's check our solution. Does 1 satisfy the equation? You don't know. Sometimes 1 could be a negative number underneath the square root, the fourth root. So you have to check your solution. Check. 2 times fourth root of 5 times 1 minus 4 minus fourth root of 2 times 1 plus 14. Is it equal to 0? Okay, let's simplify. Underneath the fourth root is 5 times 1 minus 4 is 1 minus fourth root of 2 times 1 is 2 plus 14 is 16. Fourth root of 1 is 1, 2 times 1 is 2 minus fourth root of 16. What number multiplied by itself 4 times gives you 16 is 2. 2 minus 2, 0. So therefore, our solution set is x equal to 1, the number that satisfies the equation. Okay, I hope it makes sense, and every other example is very similar to these. Okay, I'm gonna stop here.